So if you were wanting to take the derivative of a function like x plus 10 squared, we could do that, but first we'd have to find what that square is, right? We'd have to do x plus 10 times x plus 10, which would give us x squared plus 20x plus 100. We could take the derivative and we would get 2x plus 20, which is like 2 times x plus 10, right? Sure. Now, we could do the same thing for x plus 10 to the 12th, but we would have to do all those multiplications. We would, have to make sure we didn't make any mistakes. And then once we were done doing that, we would have to take the derivative and then ideally try to simplify that derivative. But what about something like 1 over square root of x plus 10? This may look like we would use something like a quotient rule, but there's no real way to be sure because we still kind of don't know how to deal with the derivative of a square root. We know if it was x to the 1/2, but what about x plus 10 to the 1/2? How would we deal with that? So what we want to discuss is something called the chain rule. Now, the idea of the chain rule is to say that if I have two functions, and I have one kind of jammed inside the other one. So this is what's called a composition of functions. Then to take the derivative of that composition, what I do is it's the derivative of that outside function evaluated at the inside function times the derivative of the inside function. Now that's a little kind of messy, but I'm going to outline an algorithm that you can follow to kind of give you an understanding of what's happening here. So what we're going to do is what you're going to see is you're going to see a function. Usually you're not given f and g, you're just given one of these. And you've got to identify what the composition of functions are there. And then once you've identified what the compositions are, then you can go forward. So the first thing you've got to do is determine what the inside function is. So if I wanted to come over here, what I could say is my inside function is x plus 10. Now, what I have to do now is determine what the outside function is. So what does this fit inside of? This fits inside of x squared because it's something squared, right? It's something, sorry, not squared, to the 12th. It's something to the 12th power, right? That's all we're thinking about is something to the 12th power. Now your third thing is we need to find what f prime is. So f prime of x is 12x to the 11th. Okay. Then what we do is we take this g of x and we plug it in to f prime. So not f prime of x, it's f prime of g of x. So anywhere you see x, you write x plus 10 to the 11th. Then we have to find g prime, which is just 1 here, because that's 1 and the derivative of a constant is 0. So then we multiply these two together to get 12x plus 10 to the 11th. And so that's kind of an interesting thing because if you'll notice, this kind of looks like the generic power rule. We bring the power to the front, we subtract 1 from the power, and then we take the derivative of the inside. Right? That's the idea here. And what you'll find is that's how this works. So this could be written as x plus 10 to the negative 1/2. So its derivative is negative 1/2 x plus 10 to the negative 3/2 times the inside derivative, which is just 1. So that's negative 1 over 2 x plus 10 to the 3/2. So notice how much more quickly that went than trying to do something like a quotient rule or anything to that sort. So these steps here, determine g of x, determine f of x, find f prime, and so on, these are going to be very instrumental in how we come about finding a derivative with the chain rule. Probably the hardest part is actually these two parts, because unless you determine what these these inside and outside functions are, unless you do it correctly, it's going to ruin everything else. So spend some time, make sure you get these, and we're going to do some examples so that we can solidify that knowledge.